Hey guys, welcome to our channel. So we started decoding the Who's Pinball Wizard yesterday, and I want to hurry up and get into this because we got a few things to get into here. This one was pretty exciting for me when I saw this decode. So this particular one in genetics, guys, tied a few things together. And so those of you who have been following along should really appreciate this particular decode. I know I did. So he plays changed, playing changed to plays. He plays changed to plays, and he ain't changed to ain't. So he fell off twice, and playing changed to plays. So if you crossed out, so what we did real quick is crossed off the PLAY because that's the same, and we got INGS, and we brought INGS down, and then he fell off twice, and there was nothing else to cross off, so just he and he came. All right, or came down. So now you have INGSHEHE. All right, we already went through in finance, as these things seem to be hitting these categories. Now we hit genetics. Now there's some interesting things here, guys. First of all, ING ends up being ING1 gene, and it is a tumor suppressor gene. And there is also an ING protein. The inhibitor growth ING family of type 2 tumor suppressors are encoded by 5 genes in mammals and 3 genes in CEs. Let's just call them that because I ain't going to try to pronounce it. But ING3 gene is where this is. So there is also an ING1 gene, guys. Here it is. Here's the ING1. So there is actually an ING3 gene, which I have a link to, and there's an ING1 gene. The 3 is a tumor suppressor. And the ING1, this gene encodes a tumor suppressor protein that can induce cell growth, arrest, and apoptosis. So the encoded protein is a nuclear protein that physically interacts with the tumor suppressor protein TP53 and is a component of the P53 signaling pathway. So, and this goes on, I'll let you read about it, guys. So that's ING. You got a couple things going on with it. And I'm sure I'm missing stuff, guys. But moving on from that, because there's your pattern right there. You got a couple of protein coding genes. Now you got SH, which ends up being the shaker gene. This is a fly-based gene, but it's a protein coding gene nonetheless. All right. So shaker gene, and SH also ends up being biotechnology at the University of Iowa. And you also have medical genetics at Lake Erie College. Just throwing that out there. That's all there too. All right. Then you end up with EHE, and EHE ends up being epithelioid hemangioendothelioma. Ioma. Anyway, I can't really pronounce it, guys, but it's a vascular cancer, is what it is. And that's, ironically, or not so ironically, coincidentally, not coincidentally, by it's Right up here, guys, is a tumor suppressing gene, and right down here is a vascular cancer. It's in the same search. I don't know the word. I can't think of the word I'm looking for. It's irony. It's a heck of a coincidence if that's what it is. But moving on, that gets you through going forwards in genetics. Now we're coming back, and you start with EH, which ends up being essential hypertension, and that has to do with blood pressure. And I will let you read. I don't think I have to get into blood pressure problems, but that's there. Then you have EHS, which ends up being electromagnetic hypersensitivity, and it ends up being a study on people with electromagnetic hypersensitivity, and I can't now find it, but right here. Metabolic and genetic screening of electromagnetic hypersensitive subject as a feasible tool for diagnostics and intervention. Um, so, yeah, you can read all about this. And my fiance probably we will probably have a video coming out at some point dealing with this subject, because we see it. We see this here, around here. We see this. We suspect those towers have something to do with it. We suspect psychiatrists have something to do with it, and giving people these drugs and these towers. And there's a whole thing to this, guys. There is definitely a whole thing to this. Electromagnetic hypersensitivity. My fiance found a doctor. What was his name? Call?
Dr. James Rubin.
Dr. James Rubin, yes. And my fiance read all about this guy. I don't have the link, but that's going to be in our video that's going to come up at some point, because we have a theory that wraps around this. It's a whole other thing, nothing to do with the Mandela Effect, or does it? Because I think it involves these towers. I think it involves the Montauk Project, what is now Project Blue Beam. All right, I think these psychiatrists prescribing these drugs are right in there, in on it, and we have a good reason to believe that, and we'll get into it at some point. But enough on that. EHS is electromagnetic hypersensitivity. All right, then you move on to GNI, and you got Genomics and Informatics Journal. And in there, you end up with, they got computational biology, biotechnology, and applied microbiology. But something that had not come up yet, computational biology. These guys seek to build computational biology is the science that answers the question, how can we learn and use models of biological systems constructed from experimental measurements? These models may describe what biological tasks are carried out by particular nucleic acid or peptide sequences, which gene or genes, when expressed, produce a particular phenotype or behavior. What sequence of changes in gene or protein expression or localization lead to a particular disease, and how changes in cell organization influence cell behavior. This field is sometimes referred to as bioinformatics, which we've had before, guys, but many scientists use the latter term to describe the field that answers the question, how can I efficiently store, annotate, search, and compare information from biological measurements and observations? This subject has been discussed previously by an early NIH task force report, and Raul Isia. It's interesting because you got some German ties in here. Computational biology is a very broad discipline in that it seeks to build models for diverse types of experimental data. Example, concentrations, sequences, images, etc. And biological systems, examples, molecules, cells, tissues, organs, etc., and that it uses methods from a wide range of mathematical and computational fields. Example, complexity theory, we've found that before. Algorithmics, we've talked about algorithms before in not computational biology, it was something else, but we've talked about the algorithms of machine learning, and there's machine learning next to algorithmics and robotics, etc. So yeah, and this goes on. I'll let you guys read about it. But yeah, that flies right into my fiance's theory about the combination of biology and computers and artificial intelligence. So that's in there too. Um, and then that actually gets you through going forwards and backwards. And let me just say, guys, for those of you who are following along, this was a fairly short decode, but anyone who's following along, this should all sound familiar. Protein coding gene, a tumor suppressor gene, the shaker gene, which is a protein coding gene, which we had before in our early searches. Biotechnology, guys. And you got some blood pressure stuff. Cancer research, or a certain type of vascular cancer. Computational biology, which ties right into the rest of that stuff that we found that my fiance has been documenting. And this electromagnetic hypersensitivity, guys, let me just tell you, people, they put up a tower not far from here where we're at, right here, guys. And I'm telling you right now, weird stuff happens on this particular corner. You could say weird stuff happens anyway. Of course it does. But there are people that literally are talking to themselves as they run across the street, but it looks like they're talking to people. I mean, it looks like they're literally talking to somebody across the street, but nobody's standing there. That happened. There's people that they're throwing their arms and screaming at someone, but there's nobody there. It's weird. And a personal story from somebody that I personally know, that my fiance personally knows, can concur that weird things are happening, and they live closer to the corner than maybe I do, even, or maybe not. It's in proximity there, but weird things. It's not. And I think it has to do with those towers. I mean, this is a common thing. There's commonality between the way people are acting, the things the people are saying that I heard myself. What they're saying to the invisible people that they're speaking or that they're yelling at is also disturbing. Um, Disturbing in the fact that these are the transmissions that we think are getting put into these people's heads, and what it's telling them is disturbing. Um, just gathering from what I see, you can argue that there ain't that many. You wouldn't think there's that many people that would talk to nobody, but it happens as a common thing on this particular corner. So, and then this comes up, this electromagnetic hypersensitivity, We've already talked about the Montauk project and Project Bluebeam, but now they're studying that. And so we're working behind the scenes. We've been kind of tying this together, been for a while, right? Mm-hmm. Yeah, we've been tying this kind of together for a while, and yeah, we will have a video at some point that addresses this, because I think it ties right into what we've been discussing, and it definitely ties into what we're decoding. And we're going to hit chemicals next, because when we were looking at that electromagnetic hypersensitivity, and I'll provide the link, I think that my link is the one that talked about the chemical sensitivity as well. So it should be interesting to see what chemicals come out of this, which will be next. And I did look into that company I said I was going to look into, the bummer, the Health Space Data Systems. And they're basically a software company, guys. I think they're just a stock market company, so I'm going to disregard my circle around them unless something else comes up. And right now, we really don't have uh, we have a backdoor potential quantum computer user, and he wouldn't necessarily be a good one, but that'll come up in my fiance's video that she'll be in. So anyway, guys, that's going to be it for now. But really, guys, this decode right here, for me, was exciting because I saw so many things that I saw before, and I saw something that tied into something we've been working on quietly, kind of, so to speak, behind the scenes, so to speak. And then it came up. So yeah, all of it, guys. Those of you who are following along, I hope you enjoyed this. We haven't. This was an interesting one, and it tied a whole lot of things together. And if you were following along, hopefully it tied a lot of things together for you too. So that's going to be it, guys. Thanks for all your thumbs up, thumbs down. Thanks for all your comments, leads, feedback, and subscriptions. And thanks a lot for watching, guys. And for now, you guys have a great rest of your day.